Hello there guys, welcome back to yet another video. Now just like always, make sure that you full power pen. What do I mean by full power pen? Full explanation need to be there and full working out need to be there because we want to use this to improve the future. We want to use this to improve the future. Alright, let's get started. Now, the first question we have is this ball here. Now we know the mass of the ball, so I'll label this as M. Now I know the resultant force, which is downward, so I'll label this as F, R. Now the R stands for resultant. Okay, we need to work out the acceleration. The equation we need to remember is Newton's second law, which states that force is equal to mass times acceleration. If you know this equation, everything else is easy. So all we have to do is rearrange force by mass. The force is a resultant force, which is this one here, which is 0.92 divided by 0.25, and the answer we get is going to be 3.7. There we go. I've just written it to 1 point. The next one is calculate the size of the force in this case. Now, if we go to the diagram, what do we know? We know that the weight is this one. The air resistance, we have no idea. I'll call it x. Okay. Now, what we know is we know that the result of these two is downwards. So F resultant is downward, and this is 0.2. Now I can see that weight point downwards. I can see that the air resistance point upwards. Now, what is the object doing? The object is going downwards, means the resultant force is downwards. Therefore, so the resultant force is the weight minus the air resistance. Now, how do we know this? It's because the object is falling with the resultant force of downwards. Therefore, the resultant force is 0.29. The weight, which we know, is 2.5. Take away air resistance, I'll call this x. Okay, and now we need to find x. Therefore, this take away this. X, this divided by minus 1 equal to x. So x is going to be 1.58. So therefore the answer is 1.58. Now, therefore the air resistance is 1.58. There we go, Newton. Nice. Now go to the next question. Now, where it is constant, and when it's constant, it means it is flat. So from here to here, this is constant velocity. Therefore, all I have to do is from 20 to about here. Okay, so therefore it's going to be from 20 to 45, because from here to here, this is where it's been moving at a constant speed. Now, next one, we're going to use the graph to show that the distance is this one. Now, distance is the area under the graph. Now, here, what we have three shapes. So we have, let's do this, we've got 1, 2, 3. So therefore, it's going to be the area of these three. So therefore, we have the triangle plus the rectangle plus the triangle. Again, let's do this. So half, base is 20 times the height, which is 15, bracket, plus from here to here, that is 25 times again 15, plus I think this is the same, so half, base is 45. Do this one, so it's 35 base times 15, and then the answer is 77. 1, 2. Okay. Now the question says we need to show that it is about, okay, not exactly 7, 10. So So this answer here is about. So this is it. Okay. Now, if you've written your answer as, if you just written this as your answer, then this is no mark. Okay. So, for example, if my answer is, if I've written this, if I've written this, then this is no mark. So therefore, I need to write down the exact answer that I got from my calculator, which is 712.5 meters, because this here is about. Again, about. Now, next one, work out the average. Work out the average speed. Now, speed we know is distance divided by time. Now, the distance we know, we already calculated. It is 712.5. Time we know 70 seconds. Go now. You can also use 1/7. So you can do. Okay. So the answer I get in this case is going to be 10. Done. Now, this is the working out. This is the full working out. We need to remember these things, how to do that. Next one. Now, this is centripetal force. Now, centripetal force, the word centripetal force is the word center in it. Okay, so it means that it points to the center. Now, which of these 4, 1, 2, 3, 4 point to the center? And it's going to be D. D points to the center. If you got this wrong, this is the working out for that. Okay. Now, the speed is constant, but why is the velocity changing? Now, velocity is a vector. Okay, so velocity is a vector. Okay. So, velocity as a vector, it has direction. So, okay, so in this case, what's happening is direction of ball changes. Okay, so you can actually see here that the ball is here, is swinging, is changing. Okay, so it's changing. You can actually see here, look, the arrow is showing that the direction changes. Now here, it's similar. We have constant velocity. Why is it changing? Again, because it is the same answer, same question. They're giving you 3 marks. Okay, so velocity equal to vector equal to has direction. So what we have, direction is changing. Yeah, because this is the circle, yeah? So the guy is running this way and then changes direction, all the way. So the direction changes, but the speed is still the same. Okay, now remember velocity. Velocity is speed plus direction. So if the speed is staying the same, okay, so that's why speed is constant, but the direction is changing, as you can see from the diagram. Therefore, the velocity changes. This is the beauty of physics. Now here we have a graph. Now this one we need to be very careful. Now 2.5 is here, so this point here. So what we need to do, we need to draw a tangent. Therefore, we're going to draw a straight line. There we go. Now tangent is a straight line that passes a point. Now let me just fix this again, so we're not confused. Oops, there we go. This is tangent. Now what we'll do is I'll take the gradient again. So now, draw tangent is done. Okay, so gradient of tangent is change in y or change in x. So therefore it's going to be from here, here, and here. So this is my change in y, change in x. So therefore change in y is going to be 10 equal 5 divided by 3 equal 2. So I have 5 and 1, so it's 5. Okay. Now the answer you get with this is going to be from 5 to 7. So this is the range. But for to get the mark, to get 2 marks, this is what you need to do. 1 mark, draw the tangent. Second mark is this one. Okay, so this is the second mark. Okay, so okay, here we go. We just do this. So first mark here, tangent. Second mark is the working out. Okay, now let's move to the next one. This is a very good question. What we have. Students find the power. Now power is energy over time. Okay, so up the stairs and so on and so forth. So therefore the guy is going up the stairs. So if it's going up the stairs, it's going up the stairs. So therefore energy is going to be GPE. Okay, energy is GPE. So GP is mGh over time. M we know is 48. G is 10, and the height is 2.9 divided by 3.4. And the answer is straightforward. The answer is, where is it? There we go. 409. There we go. Again, if you got this wrong, this is the working out for that. Next one, we have an equation again. So GPE, so find the mass. So we need to show that the mass is, here we start. GPE, go to mass, gravity, gravitational field, and height. Now what we need to do is we need to work out mass. So GPE divided by G and H equal to mass. And GPE is 4.1, gravity is 10. How do we know? It's written there. And the mass is 1. Sorry, the mass, not the mass. The height is 26, so we need to convert this to 0.26, and this will give me a mass of 1.5 kilograms. And this here is about. Again, look at the answer. The answer is saying about, not exactly. So again, if you do this, if you've written this, and this is wrong, okay, because this is not about. So the answer, so this is the answer. Okay. Now next one is kinetic energy. Of course, we need to remember the equation for kinetic energy. So Ke is half mv squared. Work out for v. So you can rearrange this. Now this half goes to the other side. It becomes a 2. The m goes down, so divided by m, and the squared, we get rid of that, so the squared becomes a square root. Okay, and this becomes, now kinetic energy is the same as GP, so it's equal to 2 times 1 divided by the mass, which we know 1.56. Okay, so the answer is going to be 2.2. Okay, so 2. Again, if you got this wrong, this is the full working out. Make sure that you got this correct. Now here, why is the actual velocity is less than the expected velocity in this? So just one reason, one way to reduce the difference between. Now the reason why velocity is less, the real velocity is less, is because due to friction. Okay. Now this value that we calculated, this is a theoretical value. This is a theoretical value in this case. Yeah, so the reason why the actual velocity is less is because of the friction. And the question says one way to reduce the difference between the actual value. So what we need to do, we need to find a way to reduce friction. And to reduce friction is very simple. Is to use some sort of lubrication, so lubricant. Or we can use oil. So pretty much we just add oil on it, add some lubricant, or we can add some grease as well. So just make it so that it can go through it easily. Because this question here, this one, we assume that there's no friction, or there's no resistance, there's no friction. So in real life, there's always friction. So to reduce this, we use lubricant. That's why in bicycle, in the chain, we need to add oil in the lubricant. Now this is a nice question there, the equation is given to us. So all we need to work out is the moment of the force. Now the lever put the force of this one, therefore force is this much, and it is 1.4 meters away, and the answer is 525. Okay, nice and easy. Now the force is this, is push Q. Okay, the rock doesn't move. Why pushing at P make it more successful? Now we know moment is force with distance. So if so what we have, P has a larger distance from the pivot, so we are identifying that the distance is larger. Okay, so it is further away. So this means that the moment would be also larger. So therefore, this increases the moment. Here we go. Now we have orbit. Now orbit has to do with gravity, so therefore the answer is going to be gravitational field. Now here, a vector quantity. Now we need to understand what's a vector quantity. A vector quantity has magnitude and direction. Okay, so it can't be this one, it can't be this one, it can't be this one, so the force. Okay. Now this one we need to recall the equation. W is equal to mass times gravity. We're looking for the mass. Mass is weight divided by gravity, gravitational field. Now the weight is 0.7. This is 10, so that was going to be 0.5 kg. And this is the answer in this case. Again, if you got this wrong, here's the full working out. Now, the resultant force is this one. So therefore, the resultant force uplift. So therefore, there's an up force here. I call this F. Our resultant is 0.5. Okay. Now, the arrow shows the force of gravity. So this is the weight produced by the thrust produced by. Okay. Now, the thrust produced by is going to be up. So therefore, it's going to be up. Now, we know that it is moving upwards. Sorry, we know it's moving upwards. So therefore, this arrow here, so this needs to be longer, so longer than the weight. Why does it need to be longer? Because it says here, because we're going upwards, so therefore it needs to be larger. And we don't know what this is, but x. So therefore, what we have is we have the resultant force, so F resultant equal to the thrust minus the weight. Now, why is it minus? It's because the weight is going opposite direction. So look. So therefore, we have x equals 0.7. This is going to be 0.5. Therefore, we have 0.5 plus 0.2. This will go to 1.2 Newton, and this is x. Therefore, this here is 2.2. Now, you get 2 marks for the arrow being longer than the weight. The arrow is labeled and the arrow is pointing upwards. So all these three play into this. Okay, so the arrows need to be pointing upwards, they need to be longer than the weight, and they need to be 1.2 labeled in this case. Okay, so make sure that that's all out. Now, kinetic energy, this is nice and easy. So the half mv squared, there's nothing crazy going on. Now here, now look at this question. This question has been done before. So look at this. What is the equations? If I go back, look, they give you 3 marks there, guys. Okay, go back. Where's here you go. This one. Why are they giving us 3 marks? Here we go. This one. Okay, so here's another gravitational potential equation. Okay. Again, gravitational there. Let's take a look at this one. let me show you the trick. I'll zoom in here so you can actually see the trick. Okay, let me zoom in. Okay. Now the trick is the following. So what we have is we have GP, so G, PE. What's next one? Mass, so I mass there. What's next one? Gravitational field strength from G. What's this one? Height. So all we have to do is just put the sign. So the first one, after the first one is always equal to sign, and then the rest is just multiply. Here we go. One mark. Done. Now we need to calculate the height. So the height is going to be again GPE. So the mass goes underneath, the G goes underneath, and then we have height. And then GPE we know is given to us. Mass we know is this much, and this is the answer. And we get 767. There you go. 667. Now we come to the last conclusion in this case. The 6 markers. What are we going to do to get the 6 markers? Okay. This is very, very tricky. Tricky or not tricky? Right, let's do this. So what we need is we need this equation. So force equal to mass and acceleration. So we need to find the force. Okay. We need to find the acceleration. Right. So we are using second law. Should have acceleration depending on the force. Okay. So acceleration, how these two link together. Okay. So therefore, if the force increases, what's going to happen to acceleration? So we need to be able to show this. Okay. So you ready? Okay. And what we do is we have this one here. We put a pulley. We put the pulley here, and then we have a hanger in this case. Okay. Now the hanger will provide the force, which is going to be the weight. Okay. Right. Of course, the weights are attached to the trolley on the string. Okay. Now, the first bullet point I'll say. So what I'll do, I'll move this away. So I'll have this here is a pulley. This here is my hanger plus weight. Okay. So what I'll do is I'll do the following. I'll say set up the experiment as shown above. There we go. So this is shown above. Okay. Done. Now next, what I'll do is going to use a ruler to measure distance. So what I'll do this distance A and B. So to measure distance A. Okay. Nice one. Okay. We're going back. Okay. Next one. Add some weight on the trolley. Okay, so we set it up. Add some weight on the trolley. Okay, I'm going to do this first. Okay. The trolley. Okay. Right. So set up the experiments above. Use a ruler to measure A to B, and then add some weight on the trolley. Okay. And the trolley. So using a so we're going to start with add some mass on the weight of the trolley. Okay, so what we're going to do is we're going to take mass such weight from trolley so we're going to take the mass from the trolley, and we're going to add it to the hanger. Now what will this do? This will cause the thing to move. Okay, so this will cause the thing to move in this case. Therefore what we're going to do is we're going to record time taken from B A to B using stopwatch. Using stopwatch. Okay, using stopwatch. Right. Now what we can also do is we can also do the following. Okay, so instead of using a stopwatch, what we can do is we can have light gates set up as A and B, and this will record the velocities. Okay, now light gates, the way it works is light gates it's just like a gate. Look, something like this. There's a laser there. When something crosses through the laser, it flags off. So we put one at A and we'll put one at B, so we can easily use this one. Now what we can do. So what we can do, we can measure, we can calculate the acceleration with acceleration is V minus U over T. Okay? V minus U over T in this case. So therefore, this will give us, okay, now put it hanger, hanger. Okay, so this is going to be the force, weight. Okay, so this is the weight. Okay, so this will give us acceleration, slightly easy. Okay, and then, so what we've done is use the light gauge to get the velocities, and we can actually use the stopwatch to get the time anyway. Okay, and what we can do is we can beat more weights. Therefore, we're going to repeat all the steps for more weights. We must repeat, say 1, 2, 3, 4, 4, 5, 6, 7, 8. So repeat. So repeat 4, 7. More weights. And then what we can do, we can say plot F against A graph. Therefore we can actually see what happens. Okay. Now this question here is a little bit like terminal velocity. Okay, so terminal velocity. So first of all, let's move it. A bit like terminal velocity. Okay, let's take a look. So here is stationary, maximum power, go forward. Okay, so when max power is applied, okay, so we have a result. Okay, so we have, okay, come on, okay, so we have only thrust as just able the object accelerates. Okay, just like with terminal velocity, instead of thrust we have weight, so therefore here we only have thrust. So at that point when thrust acts, so therefore the object accelerates. Okay? So that's the rate. Maximum acceleration. Now, as it gains speed, what happened? The resistive force increase. So as it gains speed, the resistive force increase also increases. Now, what did this do? So if it's increasing, if this is increasing, now what does it do? This reduces the resultant force. Okay. So if the resultant force reduces, so this is which reduces the acceleration. Now there's less acceleration, so therefore it slows down. So therefore it slows down. Okay? Slows down. Okay. Slows down. Well, what happened? Eventually the thrust is equal to the resistive force. But the resistive force is increasing, so eventually it's going to match up with thrust, so it is equal. And when it is equal, so forces are balanced, means there's no resultant force, means there's no acceleration, means it is going at constant velocity. Okay, constant velocity forward, which is maximum possible. Okay, so maximum, it's constant velocity forward, and it is this max velocity. You can't go any further than this. You can't go any faster than this. You can't go any faster than this. Okay. Right. Okay, and this is how we get those 6 marks there. Nice and easy. Now here we can say only thrust acts on it, so therefore this is the resultant force, because it's only this one, so resultant force. Okay. Here we go. Now again, you check everything, make sure that we're in this. Once you've done, make sure that you tackle the feedback questions.